So, Shikha students, today this video, let's learn about various thermodynamic processes. In order to learn thermodynamic processes, we should first have a knowledge of indicator diagram. Students, we know about thermodynamic variables. Pressure and volume are two important thermodynamic variables. Let's say we take y-axis and we take x-axis. On x-axis, let's say we take volume in meter cube. On y-axis, let's say we take pressure. P, we can take pressure in pascals, that is Newton per meter square. All right, students. So now let's say here we have some, you can say a cylinder. In this cylinder, we have a piston. Right. Now, this piston is moving down from its top dead center to bottom dead center, but it doesn't touch the bottom. Let's say it only comes till here. Now, students, there is air, or let's say that there is fuel air mixture ready for the combustion in this cylinder, and this is our system. This is our system. All right. Now, we know a state of the system is defined by thermodynamic variables, and the thermodynamic variables we have chosen are pressure and volume. Now, students, I want to tell you that the pressure is not the pressure which is applied on the head of the cylinder, head of the piston. Rather, pressure is the pressure of the system, and V is the volume of the system, right? So I apply some pressure on this piston. In other words, you can say I apply some force on this piston. As a result of application of force, piston moves down. Before piston moves down, let's say when the piston is here, the state of the system is defined as 1. One state corresponds to, now we know that state is always defined by particular values of thermodynamic variables. So let's say it is P1 and V1, some volume, some value for volume, some value for pressure, which we can easily measure with different instruments in thermodynamics. Now, this is a state of system. Now, students, the system moves and ultimately I'm sorry, not the system, the piston moves and the piston comes here after some time. After some times here it settles down. Let's say the state of the system is 2. Now what is the volume? This is the volume of the system. Let's say that is V2. The pressure must have increased. The pressure is P2. Whenever we compress a gas, pressure increases. Whenever we expand a gas, pressure decreases. So V2 and P2 are the state variables, thermodynamic variables, which are helping us to define the state 2. Now, we want to plot this process, the process which started from state 1 and ended with state 2 on the graph. And this representation of this process on the graph is known as indicator diagram. All right. So it's very, very important for our automobiles, for automobile engineers, which should have the knowledge of thermodynamics to be good automobile engineers. So now this is my origin. Here I have taken P, here I have taken volume. So let me first represent the state 1. State 1 is, let's say the volume is V1 and the pressure is P1. Now students, as I'm putting the piston down, pushing the piston down, you see the pressure of the gas inside is increasing and the volume is, can any student tell? The volume is
decreasing.
increasing. Beautiful. How do I represent this on the graph? So let's say this is my state 2. State 2 is represented by, again, thermodynamic variables. So pressure has increased considerably. This is my P2 and this is my V2. All right. This is my V1. Now comes what will be the shape of the graph. So the shape of the graph is, if I know few intermediary states. So if I assume the system, the process to be quasi-static process, that means infinitely slow. In other videos, I'll tell you the meaning of quasi-static process, so that every intermediate state is in equilibrium, is a representative of equilibrium state. So that means whenever the state is in equilibrium state means the thermodynamic variables are definable, otherwise not. So that means I'm able to define, on these intermediate states, the pressure and volume. Once I have the values of those pressure and volume, I'm able to draw the graph. So normally, let's say the graph is like this. Okay. This is the curve. All right. So this curve, later on you will understand it could be something like PV raised to power n is constant. This is the curve, but for starting students in thermodynamics, this is not so relevant. So this curve is defined by PV raised to power n is constant. All right. So now I have to give an arrow for this also, telling what the direction of the process. The process is taking place P1 to P2. Imagine students, by mistake, if I put this direction of process, this will mean the system started from state 2 and reached state 1. This will be wrong, because this process would give me a wrong guidance that in the starting the pressure is very high, volume is less, finally the pressure becomes less and volume is more. But no, that would be reverse of what I am doing, right? So because the piston is coming down, pressure is increasing, volume is decreasing. So this one, this arrow is a correct representation of pressure, the process from state 1 to state 2. This is indicator diagram, students, right? Now I know how to represent a process on indicator diagram, or you can also say PV diagram. This is also known as PV diagram. Let me represent different processes on this. Now I define what is a thermodynamic process. Now it might look little different from normal processes we occur in nature, like chemical processes or mechanical processes. Thermal processes, altogether different concept. A thermodynamic process is said to have taken place when some changes occur in the, any student, when some changes occur in the
State of the system.
state of the system. Beautiful. Now, Ishma, when the state of the system is changing, what does that mean? State is defined by two
Variables
or
have changed.
thermodynamic. That means how the state has changed. Either one or two or three or all the thermodynamic variables have changed their values. They cannot change the values by themselves. Yes, sometimes they can in nuclear fission, fusion, in the sun, you know. But then sometimes we give heat or we give work or we extract work or we extract heat, and then these thermodynamic variables change their values, hence they change the state also. So thermodynamic process is said to have taken place when some changes occur in the state of a thermodynamic system. In other words, we can say the thermodynamic process has taken place when any of the thermodynamic parameters or more parameters, they change. Yes, students, they change with, yes, good. Speak confidently. They change with time. All right. Because thermodynamic processes will not change over no time. They need time to change. Now, everything in this world, it needs time to for transition. You want to change your some habit, you cannot change in zero time. You need time to change it. But we should always try to change for good. All right. So, what are different thermodynamic processes? Number one is student isothermal process. Isothermal processes. Yes, students. Hello.
Yes, sir.
Listen. So, what is an isothermal process, students? You must have heard this word iso before, like isomers, then isobaric, or maybe isentropic. Iso, you have heard before this word iso. Iso is same. Iso means same. And thermal is related to what? Heat. It's
Heat,
and heat is related to what? What represents heat? Whether this
energy,
what represents heat, whether this body is more hot or it's cold. How can we see whether the body temperature? So
temperature,
isothermal process is basically a constant temperature process. Your interest will go more deep, students, when I am going to focus your or divert your attention to any isothermal process occurring in nature by itself. Can you think of any process which is there in the nature, which is isothermal process, constant temperature process? There is a state change, there is a phase change, but the temperature is constant. So, students, what about boiling process? You can do the experiment yourself. You might increase the temperature of 1 kilogram of water. Take 1 kilogram of water. You can do this experiment yourself. Take 1 kilogram of water, maybe at room temperature, let's say 30 degrees centigrade. Now start heating it. Its temperature will rise 40, 50, 60, ultimately reaching 100 degrees centigrade when more and more heat is entering this system. Right? Interesting thing happens, students, at 100 degrees centigrade. If you open the lid, you will see the vapors getting formed at the boiling temperature. In case the atmospheric pressure is 1 bar, approximately 1 bar. So at 100 degrees centigrade, it starts boiling. Remember, students, when atmospheric temperature changes, the boiling point of the water also changes. Like in hilly areas, the boiling starts happening at 80 degrees centigrade because atmospheric pressure is less. Atmospheric pressure is more. Inside the cooker, the boiling of the water happens at 130, 125 degrees centigrade. Hence, more heat is transferred to the food. The food gets cooked very quickly in the pressure cooker. So, what happens? 1 kilogram of water. Now, vapors start forming. You give more and more heat, students will be surprised. Temperature doesn't change as long as the last drop of water doesn't get converted to vapor. Temperature will be same. Oh, that's really wonderful. So this is a good example of a isothermal process occurring in nature, right, students? Now the thing is, how do we represent the isothermal process on the PV diagram? So explanation will be given to you later on PV diagram, students. Isothermal process is represented like this. It may be like this also. All right. So okay. So now, uh, having expressed and understood what is isothermal process, let's go for second process, that is isobaric process. Isobaric process. As the name suggests, bar is the unit of pressure. Iso means same. It's constant pressure process. Constant pressure. Now, students, very simple. If it is constant pressure process, can any student tell me how I will represent it on the how I will represent it on PV diagram? Can anyone answer? Very simple. Pressure is constant.
Straight.
Straight line, beautiful, parallel to x-axis is a representative of isobaric process. All right. And then, having defined isobaric process, students, now I go further to define third one, isochoric process. Isochoric process. Choric. Yeah, I don't know the origin of this word. Isochoric process is basically a constant volume process. Constant volume process. Isochoric process. So can Amitoj Singh tell me how will I represent isochoric process on PV diagram? Volume is constant. Yes, Ishma? How will I
Line parallel to the y-axis.
just see, beautiful. Line parallel to y-axis because volume is constant. This is a good example of a isochoric process. Example, practical example. Suppose I take one gas, I close it. The gas is at 30 degrees centigrade. I heat it. It reaches 70 degrees centigrade. I've done a process because thermodynamic variable is changing from 30 to 70. But this process is isochoric process. Okay, this is how I represent it. And now, students, still I go for other processes. We call it adiabatic process, widely used in thermodynamics. Adiabatic process. Students, adiabatic process is that in which no heat enters or leave a thermodynamic system during the change. So adiabatic process, let's say I have some container, I again heat it from 30 degrees centigrade to 70 degrees centigrade, but the walls of the container are perfectly insulated. Right? That's another thing that perfect insulation is never possible. Some heat will always escape to the surroundings. So imagine that this is totally insulated. The process occurred is said to have been. You might think the heat will come from here. So imagine that this is also insulated. All right, for your understanding to convince your intellect. Okay, so this portion, heat cannot come out. Why? Because heat always flows from high temperature to low temperature. So it will always flow in this direction. There will be no backward flow of heat, right? Research says that. So this is adiabatic process. How will you represent adiabatic process on PV diagram? That we'll see later on. So apart from that, students, isothermal, adiabatic, isochoric, isobaric, and then we have isentropic process. Isentropic process. What is this process, students? This is a process you can understand. Iso is same. And what is the second word, Ishma? Entropy. This is a process where the entropy of the system remains constant. I wish you all the best, students. We really want to go more and more deep into this subject, thermodynamics, so that students enjoy the subject. Don't forget to like and subscribe our channel, Learn CBSE. So the knowledge must be shared, hence our channel must also be shared. Wish you all the best. Have a nice time.